Hello all. In this lecture, we are going to discuss about GIS data models. In the introductory lecture, we discussed that GIS recreates real-world spatial data. GIS recreates spatial data in terms of layers. From the real world, different themes will be captured with different entities like a point or line or polygon, even continuous information such as elevation, boundary information such as land use parcels, etc. These informations can be combined together, can be overlaid, through which we can represent the real world phenomena. Let's start with understanding the layers. The real world phenomena normally be captured as individual layers and used to create a map. I hope you are all familiar with Google Map. The Google Maps are produced with the same approach of capturing spatial information as individual data layers. If you look at this map, you could find the points, you can find the lines, a street network, you can find the polygons, say for example river or land use parcels. So all these individual layers combined together added attributes about these entities and finally labeled and symbolized and represented as a map. So Google Map is an example for GIS data lakes. Let me discuss in detail about the layers. This GIS layers can be represented or stored as vector layer or as raster layer or as a database layer. So any spatial or coordinate data can be represented spatially by these vector and raster format and also be represented or stored in form of tables. And of course, these tables are very much required to generate these vector models and raster models. Normally, the vector model are composed of coordinates with a defined geometry and useful for discrete features, especially man-made features. If you want to capture and represent, then vectors are best. The rasters are composed of pixels and it is often used for variables with the continuous surface like environmental variables, climatic variables, and so on. And keep in mind, both the models are interchangeable and have merits and limitations. So depend upon our choice of representation and the way of representation, you can decide either vector model or raster model. Let's start with the vector model in detail and we will move to the raster model. In vector model, the spatial layers are captured in terms of points, lines, and polygons. Usually, these entities are captured separately and finally combined together to have a realistic or idealistic portrait of real world information. These vector models have both the front end information as well as back end information. The vectors have a front end geometry In this example, if you look at the layer shows different states, and if you zoom a particular part of the layer, and you can able to find the boundary with a precise geometrical shape. At the back end, these geometrical shapes have a database with rows and columns, where rows represents unique geometries. Say for example, each polygon here represented as a row, and this each polygon represents different database or attributes. Say for example, the names of the states are represented in one column, population per square mile area represented in another column, and like you can add for each entity a number of attribute informations using which you can able to map it. In earlier case, the states are colored with the attribute of state name, and latter case the map is represented with the population density using population per square mile attribute information. So like using attribute informations, we can able to represent different aspects of real world phenomena. These vector models can be captured and stored with the different file formats. The most commonly used vector file format is ESRI save file. So ESRI save file is actually a collection of several different files with the different extensions, which includes shape files, database files, projection files, and connectors. And normally all these files are stored separately in computer system. And when you want to handle this like a save file, and you should make it sure to keep all files together, because if you miss one of these file, you could not able to open the vectors. Similar to vector model, raster model also used to represent the real world phenomena. Normally, raster data includes the photographs, satellite images, digital elevation models, and even scanned form of maps or datasets. All these models are composed of pixels, and these pixels also have front-end information and back-end information. At front, say for example here, the same states are represented with the raster model. If you zoom a particular part, and this area is composed of pixels. Unlike a vector model, it is not showing a very precise geometry because the pixel size decides the accuracy or shapes, geometrical shapes. But still, this raster model is very good for representing continuous informations like elevation. Here, each cell is representing elevation information, and color has been used or shades has been used to like represent different elevational information. In front end, the color or the grayscale represent the elevation information. At back end, the same elevation information stored as database. Here also rows and columns are added, where rows represents the individual elevational values and columns represents other specific variables. Say for example, in each elevational value, how many pixels are there. So it's kind of information you can add it. And keep in mind this raster as well as vector can have database at backend. Vector can able to hold more amount of database than the rasters. Raster normally used to create with very minimal attributable informations. And of course, both the data in front end will show only one attribute at a time. Raster also available with the different formats. By extension, you can able to understand, and usually the raster file formats are larger in size, which includes TIFF format, ASCII format, image format, JPG format, and etc. And amongst TIFF is widely used for storing raster information, and JPG is widely used in a compressed manner. Say for example, if you have a data with a larger size in TIFF format, and if you want to reduce the size, then you can make it into JPEG version and you can show it. In addition to these vector and raster model, we can also store and sometimes display data using a tabular format. This tabular format widely used to transform spatial data into vector or raster model using two ways. One is joining, another one is geocoding. Say for example, I have Excel sheet. I have an Excel sheet, and Excel sheet I want to join with the vector model. Yeah, of course, you can join it using unique identifier. In both the vector model and your Excel sheet have same coding informations using which you can able to join together, and you can transfer all your tabular information to the geometry. So you can create geometry with the help of vector model, and later with the help of tables or database you can join both the geometries and attribute information. Another way of using tabular data is geocoding. Say for example, you can store the latitude and longitude or coordinate system, so coordinate information in a tabular format, and using those tabular informations you can create a point map, a line map, even polygon map. So directly also you can create a vector model or raster model with the help of tabular information. The tabular file formats are commonly read by GIS software, and most widely used tabular file formats are CSV, comma separated values, Excel sheets, and DBF. And DBF is a database file which normally considered by the save file, because save file itself there will be a DBF, as I told you earlier, which will store the database information. Other than these common data formats in GIS, there are other data formats which includes Google Earth formats, say for example KML and KMZ files, drawing file formats for AutoCAD systems, NetCDF files for scientific data visualization, LAS format for storing LiDAR information, GPX format for storing GPS unit information, especially latitudes and longitude. And GeoSAM is widely used to store geometries for web mapping and web related analysis. In addition, there are supporting softwares for general analysis or general transformation of information using a vector and raster model, which includes Adobe Illustrator, KML, CAD, TIFF, JPG, and so on and so forth. So GIS softwares can able to handle all these data formats, and some of these data formats can be handled by other softwares as well. So there is a strong connection between different data formats so that we can easily convert data from one format to another format or one model to another model. In addition to two-dimensional information, what we discussed so far in vector model, in raster model, in tabular model, we can also store elevation information or three-dimensional information using these models. Since elevation is a continuous data, so it can be better represented with the raster model like this, where the individual pixel values can be used to represent the elevation information using the elevation value. Normally, gray shades or color will be used for this elevational attribute, and you can able to visualize the third dimension of the real world. However, the vector model can also be used to represent elevational informations using points, lines, and polygons. Here also elevational information will be added as an attribute, and you can represent those attributes to understand the elevational aspects. However, since GIS is good for discrete and it will not appear continuous data like this, both are representing same area. Here it is very continuous and you can able to understand the elevation very easily, the river and elevated part very easily compared to here. But still, this data sets will also be used to understand elevation information. Say, for example, this area represents higher elevation and this area represents lower elevation. With the attribute or with labeling, you can able to infer the elevation information. The vector model and raster model are interoperable. Say, for example, the entities in vector model can be converted into raster model. Say, for example, here the points have elevational information. Using the elevational information, you can generate or you can create a raster model. That process we call it as spatial interpolation. So using elevational information, you can create a continuous model, raster model. Likewise, from the raster model, you can generate points or lines with elevational information and you can store it. Say, for example, using a raster model, the vector model has been created. So there is a high interoperable between vector model and raster model. Although vector model can able to store the elevation information, but realistic elevational aspects can be better inferred or better represented with the help of raster model. There is a special type of 3D model which can be used as a composite of points, lines, and polygons and has very precise potential applications. That is called a triangulated irregular network. It approximates the terrain with a set of non-overlapping triangles, can be constructed from elevation points or elevation lines or even from raster information. Say, for example, raster information contains elevational information using which you can construct this triangulated irregular network. This triangulated irregular network contains x value, y value, and z values for any point. If you move your cursor, you can able to understand x, y, and z values. The advantage of triangulated irregular networks are the TINs are efficient in storing three-dimensional information, especially for heterogeneous surface. But it requires a unique way of storing and unique way of handling. So it's very difficult to compare TIN model with other spatial data formats. So usually the tin model will be converted into raster or vector formats for sharing or like exchanging informations. So using all of these models, vector model, raster model, and tin model, you can create 3D models for custom visualizations. GIS offers such tools. Say for example here, a city is represented with the 3D models, all building height informations, all modeled with the help of both vector and raster data form. And of course, using these informations, we can able to create animations over time, and we can create a record videos of fly through and other beautiful applications using GIS. And of course, in addition to common GIS softwares, there are other softwares which will handle the 3D models, which includes AutoCAD, PhotoScan, etc. Data can be represented, as I told you, either vector or raster model, but choice of geographic data representation is determined by the map scale, especially the geometry of representation. So for example, in this large scale map, the road is represented as polygon, whereas in small scale map, where the road is represented as line. So likewise, in a large scale, some things you can show it as polygon, but in small scale, it can be represented as like a point. Here city as polygon, here city as point. So for example, New York here represented as point, here New York is represented as polygon. So there will be a choice of geographic portrait or geographic data representation that is decided or determined by the scale of the map or scale of the representation. Also, the data resolution of original data set decides the graphical portrait or spatial data visualization. If you want to show a minor detail of an area, then you need a high resolution data. Then only you can able to show even smallest differences. Say for example here, the same area is represented with 30-meter pixel resolution, 10-meter pixel resolution, 3-meter pixel resolution, and 1-meter pixel resolution. The 1-meter pixel resolutions will give you more precise information, more detailed information than the 30-meter spatial resolution. So data representation also controlled by the spatial resolution of original data. GIS is not an independent software, rather it is a dependent software, and GIS exchange informations with many other softwares or many other disciplines, including satellite remote sensing, 3D modeling, photogrammetry, statistical softwares, and visual design softwares, and so on. Where GIS obtain information from these models, or GIS provide information to this model for real world visualization. So GIS is highly interoperable, and using some common models also we can able to represent the real world phenomena. So with this, I just talked about the theoretical framework of different GIS data models. Now I am going to show you ArcGIS Pro software to explain different data types and how attributes are stored in different data models. Here I have opened ArcGIS software, so in which I am adding first the vector data. So for example, I am adding point information. So all metro lines, especially metro stations, are captured as points, and each station name and what like metro it is, what line, and it has a terminus or not, what are the routes it's serving. So all the informations are captured as attributes. So in front end you have a point, and at back end you have a database. Say for example here all the stations are represented as point. I want to identify the points of one attribute or similar nature. Say for example all blue points or stations I want to show. The moment you see, the moment you selected in database, the connected geometrical entities will also be selected, which means both the datasets are related each other. That we call it as geo-relational database management system. In next lecture, we will discuss about what it is. So where the information of metro stations are like captured using attributes and geometrically displayed using map. Likewise, you can capture the information as line. Say for example all the routes have been captured as line, and for this also entered with the database where different line colors, different routes and other informations, grade and other informations, you can store it as an attribute. So this is also connected with attribute. If you select in the database and it selects over map as well, so which means both the geometrical objects and database informations are connected each other with unique encoder or unique ID. So here, so this line future ID act as a unique encoder. So for example, I have a database in Excel sheet which is representing some attributes of these metro stations and metro lines, and you can connect with this database using joining options because you have a unique feature ID. So using feature ID you can able to connect all the database very easily and efficiently. Similarly, the polygon information, say for example land use parcels or neighborhoods, different neighborhoods can be captured as polygon and you can store it. And different attributes also you can add it. Say for example here for each attribute, sorry, each parcel, the demographic informations have been added. This represent the population percentage or building percentage. This represents the literacy rate or higher education attainment rate, and you can add per capita income, and you can add some other attributes, you can add whatever informations for each polygon and you can able to add it. The moment you click the geometry, all its attributes will also be represented. So in front end you will get a geometry, but in back end you will find all the attributes. Both are interconnected well with georelational database models. The same area can also be captured and represented with raster model. Say for example here I want to show the elevation of this area, elevation of different neighborhood, which neighborhood have lower elevation, which neighborhood have higher elevation, that I want to show it. Here the color these colors represents higher elevation and these colors represents lower elevation. You can change the way of representation also. Say for example, here all higher elevation I am representing with red color and all lower elevations I am representing with green color. You can change the symbology and you can show it, and you can like represent the continuous elevation information with the help of raster data. So here vector data is very good for representing discrete informations like stations, different colors, different land use parcels or different neighborhoods. Whereas the raster is very good for representing continuous information such as elevation. So both have advantage depend upon what kind of property or what kind of theme you want to represent in your map. Accordingly, you can choose vector model or raster model. This raster model also have attributes you can see. So this is unique ID of raster model, which means each row represent a pixel, pixel by pixel, and these values are representing the attribute, here the elevation. Say for example, I am just like selecting the elevation values 0 or less than that, and all those pixels be selected. So you can able to understand easily where the low elevation information are, like the future very nearer to the low elevation area with the help of these attribute information. And you can do many analysis also. Later on we will discuss about what kind of analysis we can do with the help of these attributes. In addition to these two model, you can also store your spatial information using a normal like Excel sheet. It's a polygon file. So all the polygons are represented with spatial ID and it has a values. And using this spatial ID, it can be connected with map. So which means that database informations you can like open separately with the help of general application softwares, using which you can able to like understand or you can do some specialized analysis with the help of this like a tabular format of data. Also here another like data sets are captured or stored with the normal Excel sheets with like rows and columns, where you will find different restaurants, the restaurant name and owner of the restaurant and address, which city it is and what is the zip code, and it also has latitude and longitude values. So these data sets are represent a general database, you can say general tabular data, and these two columns adding the geographical dimension to these data sets. Here we are viewing all these restaurants with the help of the latitude and longitude informations, but we could not able to visualize it. For visualization, we should represent this data in a GIS using either vector model or raster model. Say for example, I am opening this database. This database Cambridge restaurant in CSV in GIS software. Here you can see the database where all information are recorded as rows and columns, including the latitude and longitude information. So I want to like convert this database information into vector model so as to understand where these restaurants are located, rather than searching each and every latitude longitude using cursor or other manual operations. I want to show all this data all together in a single like a file. So I can able to do it using an option called create So points with the help of latitudes and longitude, for which you need to define the coordinate system. This was we discussed in last two classes about different coordinate systems. So here using geographic coordinate system because it is in latitude and longitude with the degree, minutes and seconds or decimal degree. So I am using geographic coordinate system WGS 84 datum to represent this data. So once you defined your coordinate system and the values of like x-axis and y-axis, here the case longitude and latitude, you can able to construct the data. Now see, earlier we just like looked at the spatial data with rows and columns, but here we are like, look at the same data with geometrical attribute called points. So sometimes this may be powerful for visualization, for some kind of analysis using which you can able to do it. The moment you convert into point, all attribute informations are added to those points. And say for example, if you click a particular point, all its attribute information are added for this point, including what you used to convert this table into points. So with the help of point information, sorry, like tabular information also, you can able to like generate vector or raster model. And of course, you can convert this vector model into raster model or raster model into vector model. With this, I just stop it about the discussing on different data models in GIS. I hope you're familiar with the different data models. Thank you.